Hello, my dear students. Myself, Professor M. Masroor Alam from Department of Civil Engineering, AMU Aligarh. I will be discussing today geological considerations for construction of road, railways and bridges. As you know that roads, railways, they are the arteries of our infrastructure. They help in commuting from one place to another place. We need to have very proper network of roads and railways to connect different parts of any country. Bridges, they are part of roads as well as they are part of railways. Apart from this, we also have bridge-like structures which we call flyovers. All these need some geotechnical investigations, and if they are in rocky terrains, then geology starts playing a very important role, and here engineering geologists come into picture. We can have road and railways and associated bridges in plain alluvial areas where it is not very difficult, because normally we have straight roads or railways. Only we have curves and bends where we come close to any city or close to any water body or rivers, where we have bridges also. But in hilly tracts, we have to have a lot of curves and bends in roads, especially where we can have very sharp bends. We can negotiate high angle slope easily. But in the case of railways, we need much larger curvature, less radius, and the slope also can be negotiated if it is a very gentle slope. When we make roads or railways in alluvial areas, there we have to see that what are the ground material. The ground material is of what kind of soil? Do we have organic rich soil? Do we have cohesive soil? Do we have non-cohesive soil? So we have to see all along the track that what kind of ground material is present. In the case of hilly terrains, we'll have different rock types coming across these road and railways. And for bridges, we have to have a very proper foundation after calculating the total dead and live load. In the case of roads, we have two kinds of roads. One is called as flexible pavement and another is called as rigid pavement. In flexible pavement, we use tar as the binding material. In rigid pavement, we use cement concrete as a binding material. In rigid pavement, that is concrete pavement, we also have a lot of reinforcement depending upon at what stretch this road is running. Mostly we have concrete roads or rigid pavement where we have issues of water logging. But mostly it is flexible or tar roads which we have, where we have the soil over which the road is made. Sometimes we have to raise the height of road. We create embankment by getting earth from some other places, that is borrowed earth. We raise the height, and then over this soil subbase we put lot of rocks which we call base course. which starts from larger size at the bottommost part, and as you go up within the road section, it becomes smaller and smaller, and at the top we have the finer rock aggregate mixed with tar, which is called as wearing coarse. It is called as flexible pavement because of the fact that when vehicles ply over these roads, this road flexes when it is loaded by the wheels of the vehicles. But as and when the vehicle pass out, the road flexes itself up. So that's why it is called as flexible pavement. But in the case of rigid pavement, there is no flexing. The rigid pavement top act as a rigid layer, just like a slab. So there is a slab action. In the case of rail tracks, we again have to raise the ground. We have to form embankment using borrowed earth. It is compacted. In both the cases, may it be road, may it be railway track, the compaction is done by mixing some water. That amount of water which is used for the best compaction is called as optimum moisture content. So we have to compact earth, may it be for railway track, may it be for road tracks, at optimum moisture content level. Then in the case of railway tracks, we have railways tied with sleepers. The sleepers, they are rest over the rock aggregates, which is called as rail ballast. So we have rail ballast below the sleepers, we have rail ballast alongside the sleepers, and we have rail blast in between the sleepers. So the rail blast actually is provided to allow some vibration or some flexibility for the trains which are moving on the rails. If you make it rigid, then the rails will jump out the track. So we have to provide this rock cushion at the bottom and at the side. The rocks which have to be used, they have to be very good, may it be for road, may it be for railway tracks. So in fact, how to decide that which rock is good, which rock is not good for the construction of road and railways, we have different kinds of tests. For example, for strength, we have impact test. For abrasion, we have Los Angeles test. For attrition, we have Devil's test. So we have many different tests, and there are different classes for the rocks to be used as road metal or rail ballast. The biggest issue comes when we move into the hilly regions. There what we have to make a space for the road or rail track, that is called as bench. Now creation of this bench is important because for this you may have to go for excavation. When we excavate, we create bench, we can create this slope also. The ratio of this bench width and the height is called as batter. Now this batter is very important. The angle of slope is very important because once you have road or railway tracks in the hilly tracks, then the problem of landsliding may be there depending upon what kind of rock mass we have, in what kind of climate belt we have, or what kind of weathering conditions the rocks are into. So accordingly, we have to create bench and we have to provide different measures to protect the slope movement. The batter, for example, if you want to create a bench in sedimentary rocks, then this slope cannot be very high. But in igneous rocks, you can have high slope. So with stronger rocks, we have better batter. For example, for very strong igneous rocks, the batter may be 5:1. That is 5 is the height and 1 is the width. For very poor, weak sedimentary rocks, it is the other way around, where you will have less height as compared to the width of the bench. Then this angle of slope is important. If you have strong rocks, then slope angle may be greater than 70 degree. But if you have weak rocks, then slope angle should be less than 45 degree and sometimes even less than 30 degree. So what is important is that in this case you have to go for less excavation, but in this case you have to go for very large excavation. So the most important issue, may it be for road or may it be for railway tracks in hilly region, is the problem of landsliding. So we have to make safety arrangement for our rail tracks and for our roads by installing different safety measures depending upon the slope conditions. So we may go for slope mass rating, we may go for landslide hazard zonation map, and accordingly we should install the retaining wall, a buttress wall, gabions, etc. for protecting the roads. We can also go for changing the slope of the excavation phase so that the landsliding is minimized. We have to create a fence all along the road and railway tracks so that no boulder, no big rock piece should come by rolling down along the road or along the railway track. For excavation, nowadays what is happening, that most of the roads which were existing, they have been widened. Those existing one-way or two-way roads, they are now being changed, especially in our own country, into 4-lane or 6-lane. So what happens, we have to go for more of excavation. So for this, the excavation, depending upon the quality of rocks, we can use reapers, we can use machine-mounted excavators, or we have to go for, again, blasting techniques, where we have to drill holes, and these holes may be charged with explosives, and we have to explode the rocks, and then rocks have to be removed, and then we create new bench for construction of new road and railway tracks. Now, availability of rocks is again an important issue, because in the alluvial tracts, in the alluviums, we have rails and roads. For this, we have to get rocks from distant sources. So for road, we have to have a very strong rock, especially for top surface, wearing surface, and just below the wearing surface, we have to have a very good quality rocks, which should be non-porous and should have very high resistance to abrasion and attrition. So mostly we go for quartzites if it is available, granites if it is available, for having the upper part of the road. At lower part, at base course, what we can have somewhat weaker rocks, and in that case we can use sandstone and limestone, etc. But it all depends that what class of road we are going to construct. In the case of railway tracks, the rail blast which we use, that has very high resistance to abrasion, because when rails run over the rail tracks vibrate, and with this vibration of rail tracks, all the rail blast pieces, they also rub each other, and by rubbing each other they create powder. This powder, when gets moisture from rainwater or from any other source, this powder sticks those rock pieces together and diminishes the vibration which was required for railway track to undertake. So from time to time we have to clean the aggregates, we have to remove all this powder, and then we have to relay those rail blast. A very important part of roads as well as rail tracks is the bridge. We have to make bridge whenever we have to cross a river or any arm of sea, and nowadays we can have flyovers, they are also kind of bridges. So bridges are a very important part. Now in the case of bridges, we have different types of bridges. They may be small bridges and large bridges. Sometimes we have recently, the Prime Minister of India has inaugurated a bridge which is more than 9 kilometers in length. So we have different kinds of bridges. It may be simple beam or girder bridge, it may be cantilever or truss bridge, it may be arch bridge, or it may be suspension bridge where we use cables for transferring the loads. Overall, the bridges have three important parts. If we can have, number one is abutment, this part where bridge rests on the ground. So we have abutments, we have deck of the bridge, then depending upon the length of bridge we have what is called as piers. A bridge will have a total dead load which will comprise of the material used in the construction, the reinforcement. Then it will have live load depending upon the vehicles, number of vehicles and type of vehicles moving over them. The design criteria is up in purview of civil engineers, and they decide that for different type of bridge what kind of foundation they are going to have. Most of the times they go for what is called as pile foundation for important bridges which go slightly deeper. The length of the bridge will depend upon that what is the total valley section, the width of the valley section. The number of bridges in hilly areas will be more and in plainer areas they will be less. In hilly areas you may have bridges with very large height, but in plainer areas you may have bridges with longer span and lesser height. The height of bridges are decided after measuring at least 200 years of maximum flood history. Now, as far as role of engineering geologist is concerned, our role comes when we go for analyzing the foundation site, may it be at abutment or may it be below the piers. Now in alluvial areas, the piers and abutments will be rested on the soil. So there we have to see the overall load and bearing capacity of the soil. So depending upon the bearing capacity of the soil, they will decide about what kind of foundation they are going to give. But in hilly tracts, what we have rocks. May be at abutment also and of course below the piers. Now we have to see that all the piers they are on strong or good rocks. That means they have bearing capacity to withstand the load. But sometimes what happens that in a river section, we may have different rocks below different piers. That is the most important thing that we have to see. We cannot have, we cannot think that all the rocks will behave in the same manner. So we have to see that what are the rock types below each pier. We may have same rocks through all the piers. We may have different rocks below different piers, as well as we may have different rock mass condition. That is the presence of joints in those rocks. So there engineering geology has to be employed. Apart from this, when we make bridges, what we do, we raise the height. We raise the height of the bridge by raising the ground, by making embankment. So actually what we are doing, we are encroaching the floodplain. We are embanking the floodplain. So whatever way was already there for the water to flow, once we make bridge, we restrict that place, which results into rising of water level. So a very important aspect is the decision of height of the deck, so that the water level which has risen because of maximum flood plus because of raising of embankment, it should move below the deck of the bridge. In no case water should overtop the deck, because as and when it overtops the deck, the buoyancy force will increase and there may be chances of failure of bridges. Another issue is formation of eddies. Formation of eddies along the bridge piers. These eddies form because of restriction in flow due to the presence of these piers. These eddies, they result into the circular motion of water, and this water erodes the material around the bridge piers. This problem is called as scouring. So this scouring will result into the exposure of the foundation and will weaken the foundation. So that is an important issue which has to be taken into consideration. Another important issue with the bridge is that if it is in hilly terrain, then it has to be prevented from any kind of landsliding, from any kind of flash flood, because in the case of landsliding and flash flood, the abutment may fail and the bridge may collapse. So that is an important aspect of geology as far as bridges are concerned. Another important issue is the earthquakes. If we have bridges in hilly areas and these hilly areas comes to be in seismic zones which are prone to strong and major earthquakes, there we have to analyze the overall scenario of earthquake occurrence in that region, and we have to provide extra measures below the deck. In between piers and deck, we have to install rubber sheets or ball bearings so that vibrations due to the earthquakes, they are checked. The special caution for bridges is that if we are making bridges in calcareous rocks, that is limestones or dolostone, there we have to be very particular about the presence of cavities inside the rocks. So in calcareous rocks, we have to go for detailed investigations, because in calcareous rock, the chances of having cavities and water is very high. And when we make bridge over these calcareous rock, due to the load of bridge, the calcareous rocks may collapse into those cavities. So we have to be very particular about bridge piers on calcareous rocks. Apart from this, if we have valley which is there because of fault, so then there is all likelihood that on the two sides of bridges we may have altogether different rocks with different characteristics. Apart from this, we may also have fault zone. So there we have to go for detailed geological investigation, because there may be a chance that few of the piers which are on the fault plane, fault zone, are very close to the fault zone, they may fail and they may result into the failure of the bridge. If we go for summarizing this issue of bridges and roads and rail networks, again we have to understand the river system. The river system, if it is meandering, it will pose different kind of problem. If it is bedded river, it will pose different kind of problem. If it is a gorge kind of river, then we will have different kinds of problem. So we have to understand very well overall behavior of that river on which we are going to make a bridge. Recently, the bridge which was made in Assam and inaugurated, that is on a braided river system. That's why the length of span is very high, that is more than 9 kilometers. In the same way, if you go for bridge on the canyons or gorges, then the span of bridge is less, but the height of the pier is very high. We are having another bridge being constructed in Jammu and Kashmir, which has bridge piers higher than the Qutub Minar. So there we have other issues related to the bridges. Thank you.